Everything in nature seeks stability. For example, a pebble at the top of a cliff is unstable but gains stability when it falls to a lower energy level. Another pebble, also at the top of the cliff, cannot achieve stability if there is no lower level for it to fall to. In a similar way, atoms strive for stability by lowering their energy levels. Atoms achieve this lower energy state, or stability, when they obtain the electronic configuration of a noble gas, meaning they have 8 electrons in their outermost shell. This principle is known as the octet rule. To achieve a stable electronic configuration, atoms rearrange the electrons in their outermost shell. During this rearrangement, a force of attraction develops between atoms, binding them together to form molecules. This force is known as a chemical bond. Atoms naturally tend to attain the electronic configuration of the nearest noble gas in their outermost shell to achieve stability. There are 3 main types of chemical bonds: ionic bonds, covalent bonds, and metallic bonds. Let's begin with ionic bonds. Do you know how an ionic bond is formed? Typically, metallic atoms have 1, 2, or 3 valence electrons, which they can donate to non-metallic atoms with 5, 6, or 7 electrons in their valence shells, forming an electrovalent bond. For instance, a sodium atom has 1 electron in its outermost shell, while a chlorine atom has 7 electrons. Sodium donates 1 electron to chlorine, allowing chlorine to have a full outer shell of 8 electrons. After losing 1 electron, sodium also achieves a stable electronic configuration with 8 electrons in its new outer shell. In this way, both atoms attain stability, forming a sodium chloride molecule. Another example is the formation of magnesium chloride. Magnesium has 2 electrons in its valence shell, which it can lose to achieve an octet, while chlorine needs only 1 electron to reach a stable configuration. Magnesium donates 2 electrons to 2 chlorine atoms, forming a magnesium chloride molecule. In the formation of sodium chloride, sodium, being more electropositive, loses 1 electron, while chlorine, being more electronegative, gains 1 electron. The process of losing electrons in a reaction is called oxidation, while gaining electrons is called reduction. Next, let's learn about covalent bonds. A covalent bond is a chemical bond formed when 2 atoms share electrons. Compounds formed through covalent bonding are known as covalent compounds. There are 3 types of covalent bonds: single, double, and triple bonds. A single bond, like that in a hydrogen molecule, forms when 2 hydrogen atoms share 1 electron each. A double bond, such as in an oxygen molecule, occurs when 2 atoms share 2 electrons each to achieve stability. A triple bond, like in a nitrogen molecule, involves 3 shared electrons between 2 atoms. The third type of chemical bond is the metallic bond. Most elements in the periodic table are metals, and metallic bonding occurs between metal atoms. Most metals are solids, meaning their atoms are closely packed together. The outermost electrons of each metal atom overlap with many neighboring atoms, leading to a sea of loosely held free electrons that move throughout the metal lattice. These free electrons, or non-localized electrons, are responsible for the characteristic properties of metals, such as their high electrical conductivity.